Hey guys, and welcome to another episode of Async File. In this video, I'm going to show you how to construct a binary tree. Okay, so first of all, we need to import the queue, Q-U-E-U-E, new, oh, not new, require, Q-U-E-U-E. Okay, then we need to create a node here, the constructor function, which has the data come from the data. And the left portion, the right portion to be null. Then the class will be their constructor, and we need to make it null. The constructor would be null. Okay, sorry, the constructor's root portion would construct the whole tree. It would be a rooted tree, and it would be pointing to null. Now let's go to the juicy portion, the insertion portion. Const new node would be just a new node and the new node's data portion. Okay, now what you're going to see, if I'm going to say if the root is not available. So if the root is not available, then we have to make the root to be the new node and then return from this function, because there is nothing else that we can do. Okay, now after that, what we're going to do, we're going to create a new queue, and inside the queue we are going to enqueue the this dot root dot data, or rather just the root portion. Now we're going to check while the queue is empty. So we are going to run this function while the queue is not empty. Okay, now for then what we're going to do, we're going to say a temp variable dot speak that will return the node over here, if you can see. So over here inside implementation of the queue class, you can see inside the peak we get the data portion back. Okay, so this is the temp, is where we are going to insert the data. So we are always working with the node data. Okay, now over here, now we're going to delete that, so delete queue. Then what we're going to do is, now we're going to check if the temp dot left exists, then temp dot left would be a new node. If the temp dot left exists, we are going to temp dot left, else temp dot left is going to be equals to a new node, and then we will return. If now we will check if the right portion exists or not. If the right portion exists, then we have to push the right portion, else. Okay, we are going to do the same thing, temp dot right to be the new node, and then we will return. So this is just a basic implementation of insert function of the binary tree using level order. Since in binary tree we can insert it at any given form, so we are using level order to insert it into the binary tree. Okay, so this is a code for the binary tree. Let's go and do something for like putting it in order. Let's show it in this video. So in order, so we need to receive our node over here. Okay, we are going to receive a node. If the node exists, then we have to call Inorder with node dot left, then process dot xcb out dot right node dot oh this dot underscore in order node dot right. Okay, now recursion call. Let's go and check out the in order. Now we have to call in order is the root, then we can console.log. So let's write the driver function. Insert 5, 3 dot insert 10, 3 dot insert 15, insert 20, and 3 dot insert 25. After doing this, 3 dot in order. Node 3 dot yes. And we made a little bit of a mistake over here. Let me go over here. Yes, so it will be right. Node 3 dot yes. We're getting a 10 and 5, which is wrong, obviously. And oh, all right. Node 3 dot yes. There we go. So this is the code, and see you in my next video. Bye bye. Let you see the code. This is a code for the tree, and see you in my next video. Bye bye.